It is my great pleasure to introduce you to a dear colleague of mine still, but we will continue working through Lijen, the student, Bayu. She is a professor in the School of Information Studies at Syracuse University, and her research areas are natural language processing and computational social science. She focuses on using machine learning and NLP techniques to improve information quality, organization, and access, especially in the science and health domains. She is interested in linguistic patterns that characterize people's opinions, emotions, and language styles, and their roles in information representation and sharing in science, literature, news, and social media. Her more research work focuses on computational modeling of misinformation in science news. Her work has been supported by multiple funding agencies and multiple awards, including NSF, IMLS, and Microsoft. So please join me in welcoming Bay.
Thank you. Okay, so thanks again, Daniel, for inviting me to this workshop and having the opportunity to interact with everybody. So today's talk is a summary of my team's work in the past few years. So I gave it a long title, Natural Language Understanding of Causal Claims and Exaggeration in Science Papers and News. But I would like to mention that the focus is causal language, because scientists and journalists use causal language to report science finding, and establishing causality is the sort of fundamental scientific endeavor. And as an NLP researcher, I have a research agenda of using NLP to understand causal language use in science findings and some applications such as identifying exaggeration. So in today's talk, I'm going to focus on three aspects. The first is to understand how do scientists and journalists use causal language, and is there actually a norm of such a use? Because assuming that all scientists understand like how strong the claim should be, but is it so? And if not, then are some people more likely than others to make causal claims? And the second part is about the exaggeration. So it's an application. So we try to understand when and where do exaggeration happens, and can we use NLP to identify them. I also touched upon a study that's mostly my doctoral student Inya Li's dissertation work by looking at how scientists and journalists give actionable recommendations like advice in their writing based on their finding, and are they really based on sufficient evidence? So, whoops. Oh, sorry, there's a bit. Okay. I thought I made a mistake. Apologies. All right. So our first step is to develop some prediction model to identify causal claims, and then we can start to answer some research questions. And we define causal claims into several categories. The first one is direct causal, like a sentence that used causal cues like lead to, reduce, increase, etc. And also we include this can statement, like a smoking can cause cancer, also put that into direct causal. And there's another category called conditional causal, like may, might, appears, so with some mitigation. And another large category is the correlation, like the words association or associated with or predictors. And the last category is no relationship, because some studies, like a descriptive analysis, they wouldn't look at, they don't have a potential causal hypothesis to test. Among these categories, conditional causal is the smallest one. So sometimes in other studies, people would put it together with correlational, but we put it here because there are causal cues after this may or might indicators. So we use the conclusion subsection from structured abstracts in PubMed articles as our data source. So that way we don't have to parse the entire abstract or paper to find those finding sentences. And then we trained data based on human annotations of over 3,000 sentences controlled by health topics and study design types. And with this data, we did some pretty standard transfer learning by using BERT and BioBERT. We tweaked the loss function a little bit because our data is unbalanced. And then we tried both BERT and BioBERT. And because BioBERT is trained on biomedical literature, we hope that it would give better performance. And it did deliver. It's close to 0.9, a little bit less, like 0.88 average F1 score. And now we also did a bit test on the learning curve to make sure that our test training examples are sufficient. So obviously the performance converged quickly. And because we want to understand what the model actually learned about causal language, so we did some error analysis. And interestingly, we found that both human annotation errors and machine errors, so especially in the most confident predictions the machine made. So because sometimes annotators, after doing a lot of annotations, they get tired and probably make mistakes. And also the most common prediction errors are the confusion between no relationship versus the other categories. It's mainly caused by confounding cues. In the following example, it is not actually finding sentence at all, but it used the word impact. And more interestingly, like why the sentence appears in the conclusion subsection, because it's not a finding. But after analyzing so many research papers, we have encountered all kinds of writing, to be honest, including some sentences that we cannot understand at all. So now we can apply our prediction model to study causal language use, and we focus on observational studies. We think this is the most interesting to look at causal language because a lot of debates going on, like whether researchers should use causal language to describe results from observational studies. Some people say we shouldn't. Some people say if we don't, then what's the purpose of doing this, right? So we want to examine how in the current science community, what's going on of causal language use in observational studies. First of all, how do we determine what is an observational study? We're not medical science researchers, so we rely on PubMed tag observational study under publication type. So this tag is introduced in 2014. So we have about like 10 years data. They annotate a little bit back to like 2013. Yep. So we actually, in other studies, also use machine learning to classify observational studies, but validating that method is a whole different story. And we focus on structure abstracts and English literature for the moment. So some findings. So first of all, how often are causal language used in observational studies? We found that about 22% use direct causal exclusively in their conclusion. And about 32 use some direct causal, which means at least one sentence as causal. And there were a manual estimation reported in 2010 by Cofield and colleagues on the small data set, and their estimation is 31%. So our study tried not to adjudicate that using causal language is inappropriate or not in observational study, but we can establish some fundamental pattern to see like how are they used right now. And we further look into some patterns about how people use it. For example, do people in different countries use them differently? And after breaking down the data by author's country, and we found that some countries like Germany, Italy top the list. And we actually asked the colleagues like who is from Germany or study German, whether this has some thing about first language influence on second language. And I think there were some confirmation from linguistic perspective that because there were other evidence like a German translation of English literature of other documents show like a stronger causal claim strength. So, and PubMed actually have another nice little data set that's they're English abstracts, but the paper, the full text of paper are non-English. It's a small data set, but we use it to as further evidence to see any potential first language influence on second language. And from here, we can see that some languages like German, French, their English abstracts show stronger claim strengths overall. So we have a little bit evidence so far to suggest that maybe there's a cultural issues that influence how people make a claim in terms of the strength level. And so we actually did a new study, which going further to look at who are more likely to make causal claims in observational study. So the findings that I reported was in our EMNLP 2019 paper, and this part is the preliminary results. So we want to look at author experience by the number of paper published by the first author and last author. And also we want to look at team size, like the number of co-authors and gender of the author and the country. We want to see if this has something to do with how often they use causal language. The motivation for looking at these factors is that our hypothesis is maybe with more experience, authors would have more knowledge in terms of what's appropriate use and how would that manifest. And the same thing about team size, like more people on the team negotiate the final presentation of the paper, this is probably more toward the consensus. The reason why we study gender is that sometimes we say that there is a tendency that people, especially researchers, trying to promote their research by using stronger claims. And in past studies seems to suggest that maybe men researchers are more likely to do that than women researchers. But that could change over time, right? We don't know. So, so we'll see. And we control some variables like journal impact, year and research topic, and conclusion length, because some conclusion sections have only one sentence and some have more. So we use logistic linear mixed effect regression model. And from the earlier study, because a few years passed, so we updated the corpus and almost doubled the observational study that we can find. And also we updated model with the new data set. We removed the conditional causal because it's a small category, so we merged with correlation. So the performance is about the same, a little bit better, but around the same. So first, let's look quickly at the control variables. We use nearly 500 match terms as control for different research topics. As you can see that some papers tagged with some match terms are less likely to use causal statement compared to others. And the other variable is conclusion length. We actually did a cutoff at 4 sentences because longer ones tend to be parsing errors from PubMed. And we found that the longer the conclusion, the more likely they have a causal claim. And we also control different journals, and because some journals are more likely to use causal statements, such as surgery-related journals. They report like a pre and after post-operation and what's the difference. So they tend to use causal language, and they're not counted as clinical trials. And we also control for journal impact. And we also found this gatekeeping effect that the higher the journal impact, the less likely to use causal claims. And last control variable is year. And we actually found a decreasing trend on causal language use in research, in observational studies. The 2022 year is a little bit odd because it's a big drop, and I don't think that there should be such a big drop. So we're still investigating why that happens, even though we have only half a year data. Okay, so now let's look at the main findings. So we found that team size does have an impact, that the larger the team is, the less likely to use causal claim. And also more experience the author have, counted by how many papers the first author or the last author wrote. So for both variables, more papers written, then less likely to use causal language. And also if the last author is woman, then less likely to use causal claims. And lastly, going to country. And again, for this larger study, Germany and Italy still top the list. So there's a little cluster of countries in Europe that tend to have stronger claim than others. So up till now, I think sometimes researchers debate about strengths of causal language use and their appropriateness, but we argue that there probably sometimes is not about just for promotion, but there's cultural impact on this as well. Now, let's look at the application. So now that we have tools to identify causal claim, and we're trying to see how science findings are reported in science news. And we have heard stories about exaggerating correlational finding to causation in these venues. So, so we did some study to look at that. And our work has been published at Choline 2020 and CIGAR 2021 as a demo paper. So to identify exaggeration, let me first give you an example of what we mean by exaggeration. So this is some claims from the same study, but reported in Men's Journal, and there's another company website called Waterpik, right? So magazines want to have more circulation, and companies want to sell more products. And actually selling fear is very powerful marketing strategy, like selling hope, right? So these two are quite effective. So the claim says exercise could be bad for your teeth, or exercise can lead to gum diseases and tooth decay. So quite a bit scary, right? But if you go to the original study, you will see that it's actually studying the impact of endurance training on triathletes. Right? So I'm not triathletes, and I don't do endurance training. And so hardly to say how the results applies to me. And also the finding clearly says it's a correlation. So this is an example of the kinds of exaggeration. It's hard to say like how much damage this could make to everyday life in terms of people's health. But overall, these kinds of exaggerations sort of undermine people's trust in science. And so from information quality perspective, it's not a desirable thing to see. And also, exaggeration happens in press releases. So here's another example. An original study looked at the relationship between family size and cancer risk. And it's a correlational study, as clearly stated in the paper. But then in the press release, it says larger families reduce cancer risk. Even though it says risk, but the word reduce kind of prompted people to think of it as causal. So in our studies, we actually focused on press releases instead of the general news, because prior studies have shown that press releases are a major source of exaggeration in science news. Like 33% contained exaggerated causal claims, 40% contained exaggerated health advice. That means advice not appeared in paper, but somehow made up in news reports. And 33% contained exaggerated inference to human from animal studies. So these are evidence from Samna and colleagues' work in 2014. They did quite a large manual content analysis to get these estimations. And these kind of exaggeration has some social context, like a shrinking journalism as watchdog, and also press officers under pressure to promote research. And so there's, and I think a lot of science news actually came from press releases, because many small newspapers don't have science journalists to actually developing original stories. So we developed an NLP approach for identifying exaggeration. So first we need to find those health claims in papers and news, and then link and compare them and report the discrepancies, and hopefully nudge readers through some website add-ons or chatbot or some tools to remind them. So the data collection part, we use Eureka Alert as the main source, and then map that against PubMed publications. So the claim match actually is done through inverse pyramid, because claims in news tend to appear in the title and first couple sentences, and it appears in a conclusion in the research paper. And the process of mapping is pretty painstakingly nitty-gritty. And we also use other sources to help, and use Elasticsearch and that named entity recognition to help matching them. So I'll skip the details and go to the part that how we identify observational studies in these paper and press pairs, because fewer papers with observational study tag appear in press releases. So we need a way to expand the identifications. We cannot just rely on PubMed. So we use a machine learning, we develop a model that trained on PubMed's observational study data. And the F1 score looks pretty good. But as I mentioned, to completely validate the data, say, would PubMed actually use this model is an open question. So, so we actually trained 2 claim strings classifiers. So we already done that for the research paper, and we trained another one for press release because their languages are quite different. And both models did well. So, so we start to do the comparison, and we develop a process to give headline a bit more priority when comparing the strings of the 2 different claims. And with that, we come to some findings. So the first one is how is the overall exaggeration rate? And we found about 22% press releases made exaggerated causal claims. And also looking at the trend is some good news that despite more papers published, the trend is actually going down. So that's a good thing. And we also look at the source in terms of is the press release given by journal or university, and university made press releases made more exaggeration. My interpretation is that there's more pressure for press officers to promote their research. So, so we did some also did some study to look at animal to human exaggeration. Actually, less than 10% animal studies resulted in human clinical trials. So the success rate is pretty low. And we focus on the study that used mice and rats. They are actually 96% of all animal studies. So we check if the press release is mentioned in mice or rats or not. So this is actually a simple strategy. So we found that the trend is also tend to going down. There are ups and downs. And we also found the same pattern in source difference, that university tends to exaggerate on animal studies. And we found some examples that press releases use the word model instead of mentioning animal names. So throughout the press releases, you won't be able to tell that it's an animal study. Okay. So, so this is exaggeration on causal statements and animal studies. So now I'd like to take a couple minutes to introduce my doctoral student Inya Li's work on identifying health advice in science findings. Because after researchers made their causal claims, quite often they would describe the implication and give recommendation, like how people can act upon their findings. So in medical science, this is the health advice. So we're trying to define and solve a new NLP task for detecting health advice and science findings. This is our EMNLP 2021 work, and also study how scientists give the advice in observational studies. That's our iConference 2022 paper. And in the future, we'd like to detect unfounded health advice in press releases using NLP. So first, an example of health advice. So this is a piece of advice no longer valid, that in 2020, there's a French research team claimed that hydroxychloroquine was effective in treating COVID, and they recommend the treatment, but I don't think people are doing that now. So this is one example of health advice given in research papers, and there were debates about whether researchers should do that or not, because so people who are against it saying that individual study can only report, they have limited space, they can only report about their finding, but giving advice about a treatment, one has to investigate all of relevant findings, summarize them, like takes a meta, like system review, that kind of approach to really go to recommendation. But people supporting giving advice would say that if researchers don't do it, some other people, the readers, going to do it themselves, journalists or average readers. So researchers should try and do their effort to translate their finding into recommendations. So they're for and against about this practice. So we're trying to see how researchers give their advice, when and where. And typically they appear in two locations. The first one is at the end of the abstract, and the other is in the full text in the conclusion section. Sorry, in the discussion section. I put it in the wrong screenshot here. So in the discussion section, there are more space, and there could be more sentences talking about implications and recommendations. So we used similar data method. So we annotated a corpus of sentences, finding sentences, identifying strong and weak health advice, and then fine-tune a bird-based model to identify advice. And so the prediction model, again, the BioBird model works the best. The micro average F1 is 0.93. And then we also did a manual analysis of sample of 100 papers in our annotation data set, just to see like where do researchers tend to give advice. And this distribution shows that 20% did not give advice at all, and only because 2 out of 100 mentioned advice in abstract only, and nearly half mentioned in discussion only, and like 1/3 would mention advice in both abstract and discussion. So our takeaway message from this analysis is that scientists rarely give advice in abstract only. I think that makes sense because they have to be very careful, because abstract is widely accessible, but not the full text, right? So they tend to go to the discussion, use the space to give a thorough discussion than to just mention it in abstracts. However, because 1/3 actually mentioned them in both sections, so I think it is another call for open access. And also we compared different versions of advice in abstracts and discussion, and we found that advice in abstract tend to be short, weak, and non-specific. Because if you say, like, under what circumstances should you use it, this treatment, and how to use it, it takes a lot of details, and abstract should not be the place to include all of them. We also did a little fun application of applying the model to the lit COVID literature. So lit COVID is a data source curated by NIH about all papers published about COVID. So we download the corpus and use some mesh term to filter the data, and then apply the prediction model to find all health advice related to HCQ. So we were able to find like recommendation, objection, and advice on the dose and use and cautions, etc. But so I think this demonstrates that our tool can be used for information retrieval purpose to retrieve advice. However, if we want to do like more fine-grained analysis, like we need to add like sentiment, opinion analysis to go into the level of like summarizing all the advice. Okay, so this is the health advice detection. We haven't done the part of linking, finding health advice in both paper and press releases. That way we can identify those unfounded advice. So that's a piece of future work. So to summarize my talk today, so some takeaway messages. First one, we have built good quality corpora and high-performing prediction model to detect causal claims and actionable advice in science publication. And second, we can use NLP to identify exaggerated causal claims and animal studies in press releases. And scientifically, we find that causal language use may be affected by cultural and environmental factors. And overall causal language use in observational studies is decreasing, and overall exaggeration in press releases is decreasing. So these are some good news to as the take-home message. And this is my colleagues that work together on these projects. And our work is also thanks to our sponsors. Thank you. So that's all.
Thank you so much, Bei. Really fascinating studies. So let's thank Bei. If you have questions, again, please unmute yourself and just ask them away.
Hi, Bei. Thank you for your wonderful presentation. I do have some questions. One question is that you find that some journal have this kind of issue. Did you try to analyze the characteristics of those journals, so maybe we can avoid some journal we don't read? Because when I was reading on some news article, is like it's the title tell me a big thing, and I go to the original science article is tell another thing. So which kind of journal like we should avoid, like so that we don't need to waste our time to read some low quality news?
You're muted.
You muted.
So are you saying that you are directed to a research paper by a exaggerated news title?
Yes, for example, like some news, like some journal, like they exaggerate the original research findings, right? I'm just wondering which kind of journal are likely to do this kind of work so that we can avoid reading some journals. Some how to say, like some news journal, not scientific journal, like some magazine or.
Oh, I see. Magazine. Yeah, we are actually trying to build add-ons that could so like say when you're browsing Reuters website and they are reporting on some science finding, and then we can check with resources like PubMed. So if we detect exaggeration, we can highlight that in the website in like a browser add-on. So this is something we have a prototype on limited sources because every news sources are different.
I see. And another thing I'm curious is, did you see that what characteristics does those website have that they have intention to exaggerate?
You mean popular news sites?
Yeah. The website that reports research findings, not scientific journals, like they cite scientific journals, right?
Right now, we're still working on press releases. So they're all from journal and university, like research institutions. Common news, yeah, there are just so many. It's yeah, we haven't studied, like say take common newspapers or websites. I think there are just too many, so we can only provide tools that for example, using the web browser add-on to do some filtering or highlighting. But I think, are you thinking of some function embedded in, for example, search engine like Google, so they can rank the news sources based on quality? I think they have done something, but probably not on specific article level, but overall like reputation level for website. Yeah.
I see. Okay. I think like you are thinking about tool or engineering perspective. I'm more interested in the social perspective of website but that's fine. Thank you for this your effort on this amazing research.
Thanks, Han. I want to mention that there is a panel discussion at NIH, I think, on misinformation. And one conclusion from that is that we probably shouldn't look at misinformation all equally, and because we have limited attention. I mean, scientists and government or anyone who cares about that. And so if some misinformation is not like widely circulated, we can just leave it there and not bother with letting people know, hey, here's a piece of misinformation, but focusing on those with more potential house effect, like anything that has more impact on the world. I think that's probably an important thing to begin with. Like, does this one matter? Is it necessary to debunk exaggeration or even misinformation?
I see. Thank you.
Okay, so we still have a good chunk of time for questions. Let's go ahead and unmute yourself.
Shall I read the question in the comment in the chat?
Yeah.
Let me see, where's the beginning? Sabasri has a question on error analysis part, how the data annotators are recruited, are they experts in the field? Yeah. So we started the annotation by ourselves, and then we saw that there are some challenging cases. Inga and I did the initial rounds of annotation. We thought like we're both researchers, and the causal language shouldn't require like a medical training to be able to identify, right? However, we have challenges, and so we went to psychology department and find a doctoral student who has time to help us sort out some of the difficult cases. And one observation is that we have different approaches to identify causal language, because Inga and I are from a language perspective. So we look at linguistic cues as the marker. So do they use this as causal language cue? But a researcher, like a medical researcher, because that student from clinical psychology, and she sometimes would do inference, like based on context and if this is causal or not. And so we have to negotiate like how we do the annotation to make sure that and we cannot put that much contextual information into it, because that's not what the model is intended to behave.
Still have some minutes for questions.
Yes, hello. I have one question. Thank you
Please
for
go
the
ahead.
question. I would like to ask about the performance of the algorithm. Could this method be considered on the big data scale, for example, in this field, considering that it is possible to obtain the structured abstract list? Would it be needed or even possible to run on local machines, or for example in cloud computing?
I think so. Because once we train the model can be applied to other data. I think you also mentioned about structured abstracts. We actually extended the prediction to unstructured abstracts also. Yeah, I think, was that your question? I'm sorry.
It was more related to, for example, the time performance of having, for example, 20 millions of abstracts. Is it needed for this research to obtain a good models, or for example the small sample is enough?
Yeah, we actually, because we are using BioBirdie's transfer learning models, we actually didn't need a huge amount of training data. So for causal language, we annotated 3,000 sentences, and for health advice, I think 6,000 sentences. And 6,000 is actually because we also annotated discussion sections. They tend to be long, and many of them are not health advice. So if we just use abstracts like the conclusion subsection, then we don't need that many.
Okay, thank you very much.
And Matthew mentioned James Heather run one Twitter account solely call out press coverage that extrapolates animal model results to humans. And actually there was a, I think on Eureka Alerts, I remember there's now labels to show like which study is animal studies. So I think there are more efforts to kind of make sure to clarify those information for readers.
So I have a question. I'll use my organizer privilege. So there is this sense that I feel like there are these fields that are, I guess, sexy, and but they're working on things that might not have implications too immediate to the population. So I'm thinking, I used to work in neuroscience, and people are thinking about implanting like chips in the brain, but all these are like dreams. So do you see, I know you analyze mesh terms, so I'm wondering if you saw some correlation between kind of how applicable these things are versus how much they exaggerate. So I think that things that are not really applicable to humans immediately might be more exaggerated, whereas things like heart disease and things that are more immediate, maybe they are not so exaggerated because they have like an immediate application.
That's a great question. This is actually a part that we are going to do, to look at the topics of exaggeration, the correlation to causal, to see whether it's related to like a disease or like more fundamental research. Yeah, so this is on the to-do list. This is actually what I proposed to the year 3 of my NSF project.
Great. You can use, we've used like NIH funding as a process, as a proxy. So usually they fund things that are more immediately beneficial to society, presumably. So you have more funding for heart disease, for Alzheimer's, because, you know, it could have huge benefits, but maybe you find a correlation.
Ah, great point. I'll use that.
Yeah, great. Okay, let's thank Bei again. Thank you, Bei, for your presentation and great findings. Looking forward to the next year 3 of your research. But thank you.
Thank you. Thanks, everyone.